Start recording. Hello everyone, and welcome to a limping edition of Handmade Hero, which I know is a little bit odd to say, but especially since our hero has no legs, it's hard to limp. But unfortunately, I guess Twitch suffered some sort of a cyber attack, and I'm sure it was a sophisticated cyber attack because no one ever says just cyber attack, because that would make it sound like they didn't have sophisticated security. So I'm sure it was a sophisticated cyber attack that consisted of someone running some scripts somewhere. And so there had to be a bunch of OAuth reset, key reset, stream reset stuff happening. And so we're sort of up and running, but we don't really have the Q&A system back up and running yet because I haven't gone through and figured out all the tokens I need to reset to get it to connect again. So hopefully we'll be able to do that by tomorrow, but today we may have to do basically like limited Q&A or not really the kind of Q&A that we're used to doing. But we can stream the show, and so that's something. And so if we can stream the show, we should stream the show. And so in order to do that, I guess what we should probably do is get started, take a look at where we are at, yeah. Today is day 84, so if you're trying to follow along at home, unzip day 83 source code. If you're one of the people who pre-ordered on handmadehero.org, 83 is the day that you want to start with. So let's take a look. Let's do a little bit of our own damage assessment here, now that we know Twitch is in the middle of their damage assessment. Let's take a look. So we are at the point, we took a little bit of a diversion last week, and we made a thing that does little background bitmap composites, and it was kind of cool. Like, I like that little ground composite back there that we just kind of hacked together. It was a pretty neat thing, and kind of validated the idea of how we were going to build our backgrounds. But it was kind of a diversion, and also, don't ask me why we have all these heads floating here. Sometimes you just have a lot of heads floating around everywhere. We probably should maybe, let me just take a minute and turn those off, because that's just too many heads. That's way too many heads, and we're just going to get confused if that many heads are floating around. So let's turn that back down. Let's get back to a single floating head, which is easier for us to deal with. All right, so where we are at the moment is we are trying to figure out how to finish off our world construction, so that basically ground and stuff is more of a known quantity, so that we can move on and call our Z handling finished. And right now everything works kind of well as long as you're on one level. And we sort of started working on stuff where you can go multiple levels. Like that allows me to kind of walk up our mythical staircase, which we don't have graphics for yet, but we kind of drew some rectangles in there so we could see where it was and kind of see its like sort of 3D aspect there to it, right? But we now need to kind of take it just to the final step that we haven't done yet, which is actually putting some ground in so that we can see sort of like when we have two levels, one that eclipses the other, that we can see where that is, and also so that we can, we haven't really gone through and modified our collision loop to really handle the necessary, we haven't really done the work that we need to do in order to ensure that our people actually walk on the ground, right? So right now, all we actually do is we just assume that the ground is at 0, and we did the work to put in actual markers to say what, where the ground was, but we didn't actually do the work to use them yet. So that's sort of something that we need to do. And so I don't know which order we'll tackle this in. Maybe we'll just kind of start trying to move towards a place where we are both drawing some ground and where we know where that ground actually is. That seems like probably the best thing for us to be doing. All right, so let's think about this a little. Right now we have a thing that composites ground in the background, so we did that, but we haven't actually done any work to actually put that into the world anywhere. It's just something that gets called in the main loop, so as you can see it just stays there in the upper right hand corner. And so one thing we might want to think about now, and this is kind of where I'm leaning, is just how do we get that into the world so that we can have those sort of textures as our actual ground texture, and it will move around as we move around, right? And in order to do that, it seems like we probably want to put an entity in there that is, that has that ground texture, and then when that entity comes in, it's going to get drawn with that ground texture, right? And I don't know exactly how we want to do that. That's kind of a, kind of an up in the air thing, but let's just take a look at where we're at with how we were specifying the ground things and see if there's something we can figure out that'll be a reasonable way to sort of start getting that worked into the system so that it's not this sort of floating, weird, separate thing. So we currently know that we've got this sort of space option here. This is the entity. It's sort of this concept that we can talk about empty space in the world. And basically these empty space entities we can put around the world, and they tell us where the person can walk, right? Anywhere there's empty space, that's somewhere you can walk, and anywhere where there's a bottom to the empty space, like where there's no more empty space beneath it, that was going to be our definition for where the ground is, and that seems like a pretty good idea. Now the question is, what do we actually want to do in terms of drawing those ground areas? Do we want that to be something that's defined with the space? Do we want that to be something that's sort of splatted out separately? And I'm not really sure. It's a little bit tricky. Maybe let me flip to the blackboard for a second, and I'll try to kind of go over with you what I was thinking. Let's see. Funny that we flip over to the whiteboard and it says, nowadays nothing works reliably anymore. That's kind of the moral of the story today, right? All right. All right, so let's see. Here we are on day 84. So let me go ahead and make a little space here for day 84. And then we'll go ahead and talk about this a little. So right now where we're at is we've got a pretty flexible system, right, for defining where the ground is. And so what we did is we said, all right, we're going to have sort of these spatial entities that define sort of rooms almost, right? And those rooms don't actually have to be literal rooms, right? They can be outdoors or whatever, but there's basically bounding volumes that say this is a walkable area. The user can walk around on here, and the bottom of it is considered to be solid for all intents and purposes, unless there was another bounding volume that kind of overlapped it, right? That you could work with. But assuming that you just had one like this, then this was actually ground. And so it might make some sense to say, all right, maybe the ground is just defined, the image of the ground is defined as being something that's drawn sort of on this bottom plate, right? And so that's one thing we could say. It's a little problematic though, right? Because it has this issue, and that issue is that if we wanted to start making more complex shapes, right? If we wanted to start like carving out, like let's say we also carved out a little pit here by adding another one of these, right? Then we wouldn't want the ground to be drawn in there. We'd want the ground to be drawn over here, right? And we sort of have this nasty problem at that point where how are we defining, like how would we know how this would work? How would we know how it was clipped and so on? And furthermore, like when and how is this bitmap being produced? Like if we have a giant world, I don't want to store that bitmap. I don't want to store that huge bitmap for the whole thing, right? I want to store something a lot more minimal so that I don't have to worry about storing some gigantic data set just to reproduce the ground, especially when the ground is made up of like, if you take a look at this from the top, if we're looking at this, I don't want to store this giant bitmap for the ground when really it was just a bunch of like overlapping splats anyway. At worst, I would just want to store those splats, right? Like all I'd really want to do is store the splats that went in here. And that seems to me like a much more sane way to store it because I can regenerate it pretty easily from those splats, and that gets me out of the business of storing these giant bitmaps. And so how would I do that storage along with the thing? I don't know. It would need like the list of splats, I guess. I'm not sure. But point being, it's a little bit wonky. But, we could do it. So the next question is, let's say there's an abutting one, like, there's another one over here. So it's like there's two rooms next to each other. Maybe there's a doorway in between them. And we would like, or maybe there's nothing in between them. Maybe it's just completely open, right? And it goes this direction. Now, what I'd like to do, especially if this is like, so there's a pit here, it's like that, And so if we were to look at how this thing was set up, right, there's another, it continues over here, right? This piece is this piece here. And when I'm building these things together, I want, especially if we are in an region where we want to support smooth scrolling or something like that, we don't want there to be a hard seam going across that, sort of that edge there, right? I want this splat to contribute to here so that we have a seamless texture that goes all across. And then there'd be more splats up here, right? And that's fine. But we want the ones that work across the boundary to work properly, right? So, you know, there's definitely a lot of, there's a lot of tweakiness here. There's a lot of things to think about. So what I really need to do is I need some way, I think what I'm going to need to do if I want to do this splat stuff, and I don't think the splats probably want to be entities really. I mean, there's no need to store them all as entities. We could do that. The simplest way to do this obviously would be to store all the splats as entities. But I mean, then we're really starting to talk about really multiplying that entity count for no reason, because these things are just things that produce a ground texture. And I don't know that we ever really want to start talking about them as entities. They can't really get modified much. Even if they could get modified, we probably wouldn't necessarily modify them in the way that they would be entities, right? We'd just kind of like overlay bitmaps on top of them to show like scorch marks or something, right? But we probably wouldn't actually be modifying these things. Like we wouldn't slide around the splats or anything like that. That doesn't seem like a very logical thing for us to want to do. And it's certainly not as a full entity that's going to have all these properties and stuff. It just doesn't seem like that would be necessary. Now, maybe I'll be wrong about that, and we'll see. Again, all of these things, whenever you're going through architecture stuff like this, you're just trying to do your best guess first, and you can never really be sure. When a game goes down, you know, through the rest of production, there's always going to be things where you find out you were wrong. And that's okay, but you do want to at least try to make that initial guess when you're doing your engine architecture. You want to have some guiding principles there, some reason to suspect you might be right. You don't just want to do nothing or do the easiest thing, because then you're really not doing your job setting the engine up for success, right? So anyway, and that's just, again, that's sort of the same mentality with write the usage case first, right? It's like, you want to try and do something that you really think is what the game will actually do when you're designing the engine. You want that to sort of drive how the engine works. You don't want to just do whatever's easiest in the engine or something like that, or ignore a problem till later on. You want to try and envision, okay, how do I actually make this work? Let's try to make that work in a first pass so that we have a reasonable setup there that we believe might actually be effective. Okay, so there's some pretty easy ways I could store the splat list, right? And so I'm thinking that basically that one of the easiest things to do would probably be to store the splat list as something that actually, you know, exactly as we were to use it before. So if you look at this draw test ground, you can see the parameters coming in here are essentially nothing, right? It's basically just a width and height of a buffer that needs to get composited, and then a random seed that just is like, you know, some value that we're saying to seed the random number with, and then it's just picking random values. Now, I don't think that'll be the entirety of it. I think we're going to have more complicated stuff, like when we want to have like dirt roads going, like paths going through things or stuff like that. We're going to have more information here, so it's going to be a little more complicated than that. But on the whole, if we were to generate one of these splat sets, really all we would need is some notion of how big we want this thing to be, like the radius, how big we want the splat region to be, how many splats we want it to do, or some other metrics like that, right? That's really all we need to do in order to put this thing together without actually having to store where the things went. So we don't need to store all 100 grasses, we don't need to store all 100 stones or whatever splats that we did. We can just store something that we use to generate those, and that will be sufficient. So I'm thinking that, you know, storing the splat list is going to be something pretty simple. It's going to be something like, you know, sort of some definition of the region to splat, some definition of what to splat, right? But that's really all we're going to need to do for that, I think, and then we'll regenerate it. So the more complex thing, I think, in general, is going to be about figuring out the shape of the ground, right? Because where the ground is really has to do with what those spatial entities are. that have been set up, those empty space entities. And that's a little bit more complicated to do, right? We kind of have to have some sort of an opinion about where that ground is, and it's a little bit tricky. Now, what I think I could do is basically when I'm doing the rendering, right? I'm going to know for any given screen, right? I'm going to know all the spatial entities that are involved, right? And so I'm going to have a notion of like, here's all the spatial entities that have been defined, on the screen or something like that overlap the screen, on every at every z level, right? So there might be some down here as well, and so on and so forth, right? So what I could do is imagine essentially taking slices through the world, right? Saying, okay, there's going to be some fixed number of z levels. So there's going to be some fixed number of z levels in the game, right? That are visible at any given time. We have one z level, which is like whatever the player's standing on to some degree, or whatever's fairly close to that. And maybe that is sort of this region here, right? These are the empty spaces that are sort of all lined up with where the player is standing. And then maybe there's some that are actually like below where the player is standing as well. So maybe this one is like a lower z level. So maybe this is, a z equals, -1, and this is a z equals 0, or whatever. We're not really assigning any values here, but just thinking how that goes. And so what I could do, certainly, is I could build up a region and say, okay, this is, roughly what has to be regenerated, right, for the ground. I could sort of build up that region and say, let's go ahead and build up the splats that are in these regions. We'll build them up and we'll clip them to whatever this region looks like, right? So as you move around, we'll just regenerate whatever we need to. You know what I'm saying? Because really, each z level could have its own buffer that's as big as we want in terms for caching. So we could be working on a buffer that's fairly large, right? That we just use for caching, and then when it scrolls, if there's a region of it that hasn't been filled yet, we'll fill it. But it's not quite as simple as that, because that region has to have holes in it, right? In other words, like I was saying, if this is the edge, let's say this, a better example maybe would be to say, let's say we're looking at a place where the hero is standing on some stuff here, right? And the hero is up here. And there's stuff down below. So there's a ledge that they're kind of looking over, right? And there's another region here. And so if this region here is at a different z level than this region here, then we need sort of two, right? There's two buffers at play here. There's the one that's up higher, right? That the player is standing on, and then there's that one that's lower. And we can't composite them both into the same region in terms of if we're doing some sort of lazy sort of building of what these things look like. We can't do them both into the same buffer, and the reason for that is that this layer will move at a different rate than this layer, potentially, if we want there to be that like parallax happening. Then when the hero like moves this way, right, this line is going to move this way faster than this thing moves this way, right? That's just how that's going to work. And so I don't really know exactly how we want to handle this. The easiest way is if we could just know ahead of time that there's a certain number of z slices, right? And so, what I would like to be able to do is say, all right, at a maximum, we've got some depth, some number of z slices, right? So there's like our z0 slice, our z1, our z2, our z3. And these don't correspond to actual z's in some sense. They're really layers. In fact, I could say that this is really more, it's not z, it's just depth, right? So this is like depth 0, this is depth 1, depth 2, depth 3, right? And like depth 0 might be above the player, so this is above the player. This is like at the player, this is below the player, and this is like a second layer of below, right? And so normally you don't see this one unless you're transitioning. So if the player is kind of going up into this layer, then they will actually experience it, right? They will see it come in and it will kind of blend in, but then it will become the at layer again, right? And similarly, these below layers will work the same way. Like if you were walking down the stairs, then this layer comes up at you, this one comes up at you, and then a new one comes in from the bottom, right? And the at layer becomes that above layer. So if you think about it, we sort of, what I'd like to do is have this sort of notion that the game has to work within some constraints. You can't have arbitrary stuff going on here because we're not a 3D renderer, and that would cause us a bunch of problems, right? So that's probably the way that I'd most like to look at it, because that would be really kind of easy to conceptualize. Again, the problem with it is it wouldn't let us do sort of arbitrary stuff. It wouldn't let us have arbitrary levels of ground, right? So if we wanted another piece of a ground thing in here, we couldn't have ground be doing all these weird sorts of things, right? So if we wanted to have like another ledge in there and another ledge in here and so on, that becomes much more difficult if we were to do it this way. And so there's kind of like a tension there in terms of how we want to do that compositing. Now, we could also, again, say that we're just going to do it, we'll allow as many depth layers as show up, right? That's something that could totally be plausible. But I just don't know how realistic that actually is. So, I don't know. I might sort of look at it this way for now, and then when we get in there, if it turns out that there's an easy way to make it more general, maybe we will. But I'm thinking that just based on also the way the game is sort of conceptualized, where there just isn't a lot of complex Z-level stuff happening in terms of like walking up little mounds or little things and going down, I don't know this will be necessary, because remember, this is only for the ground, so objects that are on here can be all kinds of heights in here. So we can add objects that give us sort of more height interest in here. They just won't be part of like the ground compositing stuff with the seamless texturing and that sort of thing, right? So yeah, that is what I'm thinking in terms of ground generation, is we have some fixed number of layers and then those layers called upon. Now, again, what we need to do is we need to figure out a good way of having the ground actually, knowing where that ground actually is and isn't, right? And so again, what we're looking at there is if we think about how we've defined this, if we have some kind of definition for the space where the space, we sort of said there's empty space here, and there's empty space here, and there's empty space here, or even like this, so it turns out to be just like a hole right here that you can see down into, or something like this. If we have something like that, or even if we have something that's a little bit different, where we carved out empty space for the whole thing, and then did a region, in the middle that was supposed to fill it back in, right? So, this was empty space all here, but then there was like a solid piece here, or something like that. I'm not sure exactly what, but a way of defining it so that we used a large empty area, but then we sort of filled it in, or who knows what. I guess the trivial example here, actually, I can draw it in 3D pretty easily, right? Is let's say we made the empty space like we did here, and we go back to that pit example, right? So I draw a pit entity. Empty space. It is still an entity, but you know what I'm saying. So there's a pit in here, right? And so that means that if we wanted to generate the ground for this region, right, that thing looks like this, right? This is the actual region that wants to get filled with ground, and we don't want this region to be filled. We want that to remain, this should be like alpha 0 in here, right? So that we don't have any, so that we can see into that pit, which was, the intention of whatever the level was at the time where it generated that kind of a setup. And so when we think about that, it's relatively easy for us to sort of splat in these rectangles and say, okay, this rectangle here, but it's harder for us to think about how we would do this part. And I guess what we would probably do is just splat the actual, maybe we'd just splat the actual region in its entirety, meaning including this part, and then have these fill in alpha 0 regions where they occur, right? That, seems like perhaps the more logical thing to do here. Not sure, but that just seems like what would make the most sense, So I don't know. That seems like possibly the way we might want to do it. And if we were to do it that way, it wouldn't be too difficult really for us to figure out what to do with the ground. Really all we'd have to do to figure out what to do with the ground is fill the whole area with ground, right? And then look for any empty space regions that are carving out places. So it'd really be mostly just about carving out the ground and never really about filling it in, because we could always just fill more of it in. That doesn't sound like a bad idea to me. That seems pretty reasonable. Yeah, that seems pretty reasonable. So maybe that's the way I'll look at it for now. We'll say that empty space things are going to carve out regions like that. We'll start with that. And then the other thing that we'll do is, again, we'll try to work out how we're going to do this depth peeling thing. So I guess the way that we'll maybe do that is we'll have this notion and we'll just sort things into there by ground entities, empty space entities that happen to have their min fall near one of these, wherever these depth layers happen to be, will get sorted into there as being ground. Or rather, we'll just use, I guess, the depth entities to cut out based on whether they overlap these depth layers that we're peeling out, right? Does that seem like a good idea? I don't know. I'm a little bit nervous about the fact that we're doing this a little bit ad hoc in terms of knowing where the ground is to draw it like that. But I don't know really how else we would do it in this circumstance, because again, we really don't want to go full pull and start to try and have each of these entities have its own sort of constructive solid geometry happen that then produces like a textured area that we then it seems like you'd be spending a ton of work to not really do much, since you know that the action is fundamentally taking place on a few separate planes. And so my question is just is there any reason not to just say that there's a fixed plane, like there's a fixed set of those planes, and we'll just kind of have those, we'll just acknowledge those and build them that way. Does that seem all right? I mean, that seems pretty reasonable to me. I don't know. That seems like something that we could work with. And so really the only question we have then is, if we need to produce a region, right? If we need to produce one of these regions, the question is, what are the splats for the region? And what we could do for now is say, well, we're just going to produce those splats purely based on some, we won't even store what the splats are, basically. We'll produce those splats entirely from some kind of a random number, some kind of a random number that's seeded off where we are in the world, right? So, if you think about it, let's say that we're going to produce this region, we've got some buffer, and we're trying to fill this area, right? If we imagine whatever, there's sort of some underlying resolution at which we want to consider splatting, right? We could just say, all right, for each of these areas, and this is maybe the 5-meter radius like we were doing before, for each of these regions, wherever the center point is, we just use that as the random seed. We do the splats for this region, right? And so for every region that we want to composite, we just see all of the tiles that would overlap, very much like our tile chunk system works, for example. We just see all of the overlaps in that area, and we do all the splats that we would need to do that could touch that area, right? But we don't actually store anything for the splats. They're just generated based on the spatial location, right? That seems pretty safe to me. Can't think of any reason not to, really. So let's see. Let's try it that way, and we'll see what happens. So let's first modify. Let's first get it working just with a single ground plane. So the first step, the step we'll try to start today, with a single ground plane. Let's just try to make the ground plane scroll infinitely in all directions. So when we walk around, when our hero walks around, there will always be ground, and it will generate, and it's always fresh ground. It's new, right? So, and it's never, it doesn't repeat. It's not a repeating texture. It's being generated on the fly, right? Let's see if we can do that. We've already sort of got a little bit of that happening with the draw test ground. Let's see if we can do it so that will work, right? So the way that I'm going to do that is I'm going to use exactly all the same stuff we already did. So we've got this loaded bitmap ground buffer here, right? But I'm going to take that ground buffer and I'm going to make that ground buffer relatively large, right? So what I want to do is I want to say that the ground buffer is going to be big enough so that if it were, if it had to scale up one, right? If it had to scale down one. So for example, if the ground buffer, if I started walking up a stairwell and the ground had to recede into the background, there would still be enough apron around it so that it would be able to cover that region, right? And so I'm not sure exactly how we want to. We're still at a little bit of an unfortunate place in terms of not having written the renderer yet. We don't know exactly all the ways in which this should be driven. But we do have that input buffer, and we know how big that is, right? So we know that like our actual render buffer there that got passed into us, we know how big that is. So we could start with that size, right? So we could say, the screen width, or I should say the display width or something like that. I don't know what we'll call it. We'll call it screen width. So we could say that the screen width, right, is known because we got it from the platform layer. Right? When the platform layer passed us our game on-screen, off-screen buffer, it told us how big that was in pixels, right? So we actually do know that, right? So we've got those two things. Now, we also know that we're going to have some amount of z-scaling that will make these things appear smaller as they recede into the distance, right? So if we wanted to think about it this way, we could say, all right, let's suppose this were a real, the screen width, right? So then we could say, well, our lowest depth layer has to be big enough so that the pixels, right, that are in it still, cover the screen. Trying to just give you an idea here of what I'm talking about. If this is the screen, then if we wanted to have ground that filled this region, all we would have to use, right, is we'd just use a buffer that was the width of the screen times the height of the screen, right? It's like that's width by height. That would store all the pixels that we're going to display on the screen, right? But now, if we imagine that this screen actually recedes into the distance a little, because the hero walks up the stairs, right? So if the hero walks upstairs, now we have a case where this is actually the screen, and what used to be the screen is actually like a lower depth level, right, that we're looking into. And so now it has to actually be wider and taller, right, in order to actually fill the whole screen. And so what we need to know there is what our z-scaling factor actually is between the very top level and the very bottom level, right? And we don't actually know what that actually is yet, but we can at least set ourselves up for success by saying that we have some maximum z-scale that's going to happen, and maybe that's half the size or something, right? That would be all we would actually have to do in order to, that would be the minimum we'd actually have to do, right? The maximum size we'd have to do for one of these buffers. Now, at first, we don't have to worry about that because we're only allocating one of them, but we're going to allocate more of them. So the first one could actually be just that one size. And so what I'm going to say here is just our overscan, our ground overscan, I guess. We'll say that that's 1.2. And all I'm doing there, I'm pulling that number totally randomly out of thin air, is we're going to overscan a little bit. We're going to compute a little bit extra so that when we scroll, we don't have to update quite as often, right? It doesn't have to update every frame necessarily. So we might want to just do some overscan to make it so that we have more time there. And really where that comes in, that'll come into play later, probably when we're doing multi-threading, when we have threads in the background that are doing stuff like ground compositing or whatever else. We don't want them to have to hit every frame a complete update. And so, like, for example, when the hero walks sideways, we want, when this sort of starts to scroll, we want there to be time where we know we have to fill in something. We want there to be some time where we can do that, right? So I don't know, maybe it's more than that, I'm not sure. But let's go ahead and say that we've got some ground overscan of having an extra half there. And so what we end up with in terms of our base ground level, right? So our ground buffer width is going to be whatever the screen is times that ground overscan, right? That's going to be its width. and we can round that guy. So round, and same with the height, right? The height's just going to be that same thing. And so now that we have those, we could say, all right, let's make an empty bitmap that's the ground buffer width and the ground buffer height, like so. And that'll just give us that backing store that we wanted. Sorry, that's an indirect reference there. What's the question? Not casting to a reel? Are you happy about that? There we go. So that gives me enough space. Now, I don't know, we probably need to start using the transient area, but that's a separate issue. So that gives us enough space now to produce something that we could scroll with. And so now what we need to do is we need to go in and actually partition that into something that we can use in a more logical way, right? We need to be able to scroll that around. Now, what we can do first, right, is we can introduce some notion of where the ground is so that it moves with the camera. That's like obviously something that we would want to do as well. So what we could do first is let's get it moving with the camera, and we're going to want it to move with the camera in such a way that, you know, for those of you again who aren't familiar with this, when we move with the camera, when we move this with the camera, what's going to happen is we've got the buffer here, right? And we have the screen here that we're seeing. Now, as the hero moves in a particular direction, it will get to a point where the buffer is at like the end of where it could logically be, right? Like we can't move any further over. And while the player is moving that way, they're going to keep moving that way. What we then need to do is recenter that buffer. So then what we do when we come down here, when we've got the situation here, is we sort of teleport back to like here, right? So as the player continues to move in that direction, we then teleport them back into the space in the buffer by basically taking all of the stuff that was in the buffer here and copying it backwards, right? So we displace the player's view into the buffer backwards, and we also move everything that was in the buffer backwards, right? So that now it's like that, and now this region is ready for filling, and we can fill that with new ground splats, and the player can keep walking that direction, right? So we're just kind of like doing that kind of standard sort of allow them to scroll through it, then fill, then copy back, fill, allow them to scroll through it, copy back, fill. And like I said, this won't be multi-threaded at the moment, so we're going to have a hiccup every time that happens because we composite very slowly right now, so that'll happen, but that's fine. That's not a problem. That's something that we'll solve over time, and so we'll just, we'll be okay with that. But we got to get the rest of the stuff working before we can think about stuff like hiding that computation time, or speeding it up first of all, and then also hiding it by putting it on a separate thread or doing something else. So what I want to do now is I want to say, all right, let's actually move that thing. So what I need to do there is I need to have some notion of where the ground buffer is relative to the camera, right? So I need to kind of know, where is this? And probably the easiest thing to do, I guess, is to use our sort of location stuff like our camera P, right? It's probably easiest to use the ground buffer as one of those. So we'll start it out coincident with the camera, then we'll let the camera move away from it, and then when it gets too far, we'll kind of snap it in, right? That's what I'm thinking anyway. So if I wanted to do that, the first thing that I need to do is I need to say, all right, we're drawing a bitmap that's the ground buffer here. We need to know where that ground buffer is relative to the camera. We know that there's the screen center X, screen center Y, right? And so if I was to draw it like this, screen center X, screen center Y, well, it would also kind of have to be offset by how large it was as well. So there is that. I think we want to basically draw off the center. So that's the computation I'm going to use. So we'll do ground X and ground Y like so. So if we put in the ground X, ground Y here, then what we need to compute is from the screen center, we need to move back to the upper corner so that this bitmap is still drawing out of the upper corner. So we need to subtract however big that ground buffer actually is, right? We need to subtract half of that to move back to its appropriate location. So I'm just going to do that here. Again, pretty straightforward, nothing. The same math you've seen me do on here a billion times. So that's going to draw it at the center, I believe, of the screen. And that's exactly what it did, so that's good. And so now what I want to do is I want to displace it by however much the camera has moved, right? So I'm going to make this I think I'm going to make this into a V2. Why not? Just so it could be a little easier on me. And there we go. And so if I go ahead and make this ground now displaced by that difference, you'll remember that we have a very easy way to find that out. It's in here somewhere. Let's find it again. Subtract. That's it. So if I want to take two of these guys and subtract them, I want to see basically how far is the ground buffer from the camera, right? So I've got that game state, that camera P, and I've got that ground buffer P. I want to see how far away those are, and that returns me back, I believe, a V3, right? And so that's that delta, like so. Now I'm going to ignore the Z of it, but later on I think we'll probably want to use that because we're going to use that for doing like the ground scaling and other stuff like that. So we'll probably actually use that later on, just not right now. So I'm going to go ahead and add that delta in, and oops, I got to actually pass the game world there probably, huh? World position, and these want to be addresses, so I've got them. So now if I run it, we should see it move, and it is moving. And so, oh, well, you know, it's moving, but it's moving in pixels, not meters. This is in meters and this is in pixels. This is actually a render operation, so we need to actually take and do our meters to pixels here so that we can do our rendering properly. And I feel like that was already, it's also going the wrong direction in Y, which is because, again, we kind of need something that does our render transform for us. That's what the renderer would normally be doing, and we haven't written it yet. And it's kind of annoying to constantly have to do this ourselves, right? But, you know, it's one of those things that do we take the time to go do that, or we just keep fussing with this stuff? And it feels to me like we want to just keep fussing with this stuff for the most part, just because, you know, you got to kind of pick and choose when you do each individual battle. So like, you know, that delta there, we want it to be, you know, we want it to be in our pixel coordinate system, and it's coming out in our world coordinate system where Y goes up, which is always going to be wrong. So anyway, yeah, that's what we would have expected. So now it's locked with the world correctly. We probably want to start by saying that at the outset, it's where the camera is, right? That seems like a pretty sane thing to do. So our game state ground buffer P, you know, should start out being wherever the game state camera P is, like that. And then when we walk, it should, you know, be there, right? And so what we need to do now is we need to say whenever our ground buffer would be getting to the point where it would run out of pixel coverage, right? We want to snap it towards the camera's direction, right? So we need to do like that copy, and we need yeah, we basically need to do the copy, and we need to change the location of it. So what I'd like to do for that, first of all, what I'd really like to do is not be constrained anymore by these trees. So I think what I might do is temporarily turn off this generation stuff entirely. So let's go ahead and do that. Let's go ahead and get rid of those. Let's get rid of that first. To do, put the walls back in. Don't forget. Yeah, but while we're doing this, you know. So there we have it, right? Now I can just walk around randomly. And like I said, the problem is that when we get to the end of the ground, we can't, oh, you know what? We need more empty space though too, don't we? Because we wouldn't have much empty space. But this might be enough for me to do my testing on it anyway, although I could make that empty space just really large as well. Let's take a look. Where is the empty space adder? let's see, the empty space adder, add standard room is right there. Well, you know what else I could do? This is what I'll do. I'll just say that we'll go back to the old way of forcing it not to create a Z door, right? So when it does this random choice thing, I'm gonna go ahead and say no, it's only allowed to generate flat stuff, and that'll let me do my walking that I wanted to do. So there we go. Now we're good. Everyone's happy. Everyone's smiling. Good to go. And similarly, I think we can turn off the thing that we had a thing that only generates like one room or something like that, right? We stopped doing our actual room generation in some way. We can probably put that back in now, right? So that we have more rooms with more stuff in them. All right. So now we've got, those rooms back. We can walk through them. It's all good. And so now let's just try to make it fill with ground. You know what I'm saying? So when we walk up here, right, and and we walk into this room, we want there to be ground in here as well, and we want that to just be constantly generating itself, right? So how do we do that? Well, first thing we probably want to do is when we actually generate stuff here, we want to generate the screen in some kind of intelligent way. So let's think about how we want to do this. I guess it's kind of a rote issue. We don't really need to tile it. This is pretty straightforward, I think. So I think if we do our draw test ground thing here, right? Really all we need to do is say when you do draw test ground, make sure you fill the whole buffer, right? So in draw test ground, when this is doing its thing, what we want to do is instead of doing this radius thing here, what we want to do is generate randomness that goes out to the edges, of the actual buffer, right? We want something that's going to be big enough that way. Although again, if we're going to regenerate the seed properly, we need to do that on the tile boundary. So here's, I'll just draw that out. We'll actually say what I was thinking there. So what I was trying to say is gets back to the thing I was talking about before. So what'll happen is we're going to have a buffer, and the buffer is going to be filled with ground, right? We are going to move, like I showed before in here, and when the player moves off, let's say they move off this side of the screen, we're going to have a problem where now we copy this part of the buffer, we copy it into here, and now we need to fill in this part of this buffer, right? Now normally, if we just had a repeating tile texture that repeated everywhere, all we would have to do is just call and say refill this region, and it would just do it. It would be easy, right? But that's not what we have. We're randomly generating what goes in there, and it may be fairly complicated. Like there may be stuff like things that run through here, and we want to generate stuff on them and stuff. So really what we need to do is we need to consider this in places where we can guarantee that we generate the same things every time for that region. And in order to do that, like I said with the splats, if we wanted to make the splats be procedural based on just where you were in the world, we need that to be some fixed thing that isn't randomly getting moved around by how this thing moves. And so I think the only way to do that, really, honestly, is to break it into chunks. So we need to sort of do chunks where we can say, okay, if we're filling anything with this chunk, we kind of use, we use some known value to produce the splats in that chunk, right? So I think draw test ground is going to be like draw ground chunk or something like this, right? It's going to take a loaded bitmap buffer, right, which is what it's going to draw into. But then it's got to take a little bit more information so it knows what it's supposed to actually do. And I guess when I say draw ground chunk, so when I say draw ground chunk, there's a little bit more to it than that. There's like, we're drawing, we have to, yeah. Let's put it this way. We have to know what the location is of this chunk, I guess. So we'll actually use whatever its world location actually is, let's say, to do that. There's a lot of stuff that's complicated here. I'm trying to explain them in a good order, if that makes sense. So this is the chunk P, right? So when we draw a ground chunk, we're going to want to know whatever that chunk P was, and we're going to use that for something. And that chunk P is arbitrary. It doesn't really matter that it's where it is in the world. It just matters that for any given location that we're trying to redraw, we always use the same initial position for it, input position, so that the random stuff comes out the same, right? So we need to know that. We have that buffer, that's what we're actually drawing into. And then we also want to be able to say, okay, when we're drawing into this thing, we need some bounding region, right? Because we don't want to recomposite stuff that's in the bitmap that we already had. So we need to have some kind of like a clipping region as well that we use. Now there's a trick we can use for that, so I guess I'll ignore that temporarily for now, and I'll show you a trick we can use for that so we don't have to do it. But anyway, when we come in here, our chunk P, let's figure out some way to do, we'll use this chunk P to generate our random seed, and that'll just be like, like the chunk X, the chunk Y, and the chunk Z. We'll just grab those out and just full on do complete nonsense here. I don't even pretend this is reasonable when I'm typing in, but there you go. Yeah, not, so let's do something even more ridiculous. So there you go. I've typed in some absolutely ludicrous things, and really I'm just trying to take these three numbers and produce a random seed out of them. And now when we get to random number generation, we might want to say, look into Wang hashing here, or some other spatial seed generation thing. We might want to try and do something better for generating random numbers off of positions, but for right now, that'll be fine. So once we have that, what we want to do is we want to generate chunks that we know will sort of fill in this region for us, and we'll do a better job of that later when we get to world generation for reals. But for right now, what we want to do is put those stamps down so that they kind of nicely cover that space. So what we want to do is say, instead of radius being to some fixed value here, which isn't particularly useful, we probably want to get rid of this notion of meters to pixels here and say, let's actually use the size of the whole bitmap, right? Let's actually use that as our offset. So what we want to do for there is we'd want to say half the height. We could actually use a random unilateral here and move it that way. So let's just use a random unilateral, right, from the series in both of these. And we'll use whatever that input width and height is, right? So in fact, I'll pull these out into something like that so that we can have them at the ready. Maybe I'll even just call those width and height. Okay. So let's do this. This is the width times random unilateral. This is the height times the random unilateral. And that produces what we wanted. We can then actually, we don't need center at all. Center doesn't have to happen. Radius doesn't have to happen at all. Offset, none of this stuff has to happen. So really, I think the only thing that has to, really nothing has to happen. It's just the offset minus the bitmap center, right? Oh, we're almost at the Q&A. We'll go ahead and wrap this up. Like I said, I don't know if we're going to be able to do Q&A today because we haven't regenerated OAuth keys and Lord knows what else. All right, so if I do that, we were basically doing the same thing here. We didn't really compress this code very much at all. It's sort of still all kind of janky in here, but that's okay. Again, everything in its time. So if I go ahead and get this going here, let's see, v2i width and height. That's not necessary anymore, so we can do that. Draw test ground. Okay, that's draw ground chunk, right? There we go. And we can pass in for now. We'll pass in the ground buffer P, but that's not actually what we want to pass in. That'll be different later on. But let's just see if this properly fills things out as it should. Yeah, so there we go. So now you can see that buffer is getting the whole buffer is getting filled in. Unfortunately, we haven't done enough splatting to actually cover it at any reasonable amount of detail, though. So we probably would want to increase those hundreds to something higher, but that's a separate issue. So again, how to do coverage and stuff there is sort of a separate thing and that we'll think about later. But so now we've at least got some ground that spans the first region, and mostly all we'll have to do is figure out how to do, again, that update as we move, and then we'll sort of have our progressive ground working. All right, so let's go ahead and try to do a little Q&A. I think we might as well try, but unfortunately, I don't actually know. I don't actually know how well this will work. But let's at least do a couple minutes Q&A and see how it works. Please prefix your questions with Q:, although I don't know that that'll actually help, but I can at least try to scan for those manually, even though the Twitch thing is broken in terms of showing us what's actually there. Let's see. When will we fill the entire game window instead of having all that black space? Actually, that's intentional. So I guess one thing that might be a problem is people who are new to the stream might not realize that we're in development stuff. Like, if you wanted to see it fill the whole screen, you could already do that. That's not really a big deal. But in development, what you want to do is you don't want to ever, pretty much, look at your actual game output as in full screen. The reason for that is you may have drawing bugs that happen off the edges of things and stuff like that. And so usually what I do is I always have stuff that looks essentially like this when I'm working, and we'll probably go even further than what we are doing right now and actually show the way that our debug will work in the future will be something where this is actually centered but not filling the whole screen. So basically this thing here will be centered in the middle, and we'll draw a little bit outside of it as well, and we'll verify that everything is drawing properly, and we'll have like a safe region marker that shows us so we can see what's happening outside the game area. Because showing just the game area, that's a view for players. That's not a view for developers. Developers generally shouldn't be looking at a view that just shows what the player will see. They should be seeing more than that, and they should be looking for problems. And so typically what we'll end up with is more stuff out here, and maybe this will be centered, but what we won't do is draw full screen in general. That's only a thing that we'll test periodically to make sure that it works properly, because that's what the players will do. And when we're in sort of final testing, we'll maybe do a lot more playing with it in that mode, but that's not the general mode we want to be in for developing, because it doesn't show us, it won't be showing us as much as we need to see. Hopefully that makes some sense. Not seeing a lot of questions here. Are some of these issues with dealing with display on multiple levels stemming from the lack of a z-coordinate for the camera to just do a lerp on? No, not really, because we have a z-coordinate for the camera. We actually know what that is. Most of the problem with the thinking through z issues is largely just because we don't have actual 3D geometry, right? So if we were to build the whole game in 3D, then this wouldn't be an issue. But as it is, there's some things, a lot of things get easier when you do a 2D game. Mostly the asset creation, right? Like your artists will have a much easier time in 2D than 3D. A single artist can do a whole 2D game by themselves and it can look great. 3D, not so much. Like you're not gonna have one artist do Call of Duty, right? That's not on the table. And so you get some benefits when you go to 2D because your art quality, for the number of artists you have, your art quality goes up dramatically, and that's a good thing. But some of your programming complexity while a lot of your programming complexity also goes down because you don't have to deal with all the asset pipeline stuff, which is a huge headache for 3D, and pre-processing and all your shader stuff, all that stuff. That's a lot. There's a whole bunch of programming stuff that gets simpler, but there are some programming things that get more complicated if you want to do interesting things with it. Now, we could have cut out all of this and just said there's only one Z level, right? And then you wouldn't have to do any of the things that I've been talking about. Also, you could have said you don't move smoothly up stairwells, and that would be fine as well. So basically, like, I would say that if you wanted to not try to tackle hard programming problems, we could have done that too. And that's not a bad thing. It's just that since this is a programming stream, I try to do things that are more complicated than the simplest, right? I try not to just do whatever would be easiest for us to do, because I'm not really that interested in teaching people how to do stuff that's simple. I feel like if you want to do something that's simple, you could just go grab GameMaker or something, right? And so I want to show you how to do is push a lot of boundaries and do a lot of interesting things with the code. And so that's what we're doing. Like procedurally generated ground is a good example of something that you may not be able to do if you just grab an off-the-shelf tool. And so we want to do stuff like that, because if all I ever show you how to do is just rebuild exactly what's in some off-the-shelf tools, that's a good thing for some set of programmers, but also doesn't encourage some of the things that I would like to encourage, which is pushing beyond what you would just be able to do with a simple basic tool that you could just buy, right? If no one's asking related questions, could you ballpark a time frame when adding a font and text rendering system will become useful or necessary? I would say it's going to be right here. It's actually already on the schedule, I think. It's right there. And the answer is not long, actually, right? We've got some hard things to work through here, none of which I think will really require font for display. But then we're going to get into stuff like asset streaming, which you really want to have some debug viz stuff for, and you really want fonts to be in there at the time for debug. They're the debug fonts. You don't have to do final fonts, but just debug fonts. And for folks that are asking stuff like any advice on publishing my first game, and stuff like that, that's really stuff we talk about more in the pre-stream. So this is more time for the programming questions. If you want to come back about 15 minutes before a scheduled start time and ask those questions, we could totally cover them. Although, to be honest with you, I don't know very much about game publishing. I'm not a publisher, I'm a programmer, so you'd probably have to ask a different person. All right, doesn't look like we really have any questions. Like, I don't see many programming questions on here. As for what's the most, some people are asking, this is a very standard question we get a lot, which is what's the most efficient way to learn C++? Or what's a good tutorial for learning OpenGL with C++ and so on, with C and so on. I don't really know. I mean, one of the reasons I'm doing this series is because I don't know the best way to teach where people should go to learn things. There aren't a lot of good learning materials out there. There's a lot of bad learning materials, but finding good ones is pretty tough. And so I don't really know what I would recommend. There are some reasonable, like the arc synthesis tutorials for the OpenGL question aren't bad. I don't know where they are, though. Let's see. Does anyone actually link to the arc synthesis tutorials in here? Here we go. Oh, no! Oh, no! Don't tell me they're gone. Are they actually gone? That would be awful if they were gone. The arc synthesis tutorials, if you can find them, would actually be a good place to go. But I don't know, I hope they're not gone. That would be real bad. Maybe I'm spelling it wrong or something. No, I don't know. All right, well, if the Arc Synthesis tutorials are gone, I don't even know what to point you to for a good OpenGL tutorial. We'll be doing some graphics API on the stream. Maybe if we're lucky, Vulkan will be ready, and we can do that. So we'll be doing one later on, but right now, the Arc Synthesis tutorials were pretty good, if I remember correctly, but, you know, they look like they're disappeared or something. You mentioned offloading ground drawing to a separate thread to prevent hitches. Is it possible to offload the drawing work over multiple frames? And would there be any benefits over either method? Yeah, my intention would be to offload it to a separate thread so that it would happen over multiple frames. And the reason for that is because usually there's just a lot of CPU power sitting around that, you know, especially for a 2D game, where once we start taking advantage of the GPU for rendering, we're going to have probably cores sitting around not doing anything on the CPU. And so what I'd like to do is have those running completely asynchronously from the main thread, generating stuff that we might want it to generate. And so I think we'll probably have like a CPU that's doing a lot of background loading and decompression or who knows what. And we'll probably also have a CPU thread that's doing a bunch of generation along the same lines. And I don't think those will need to be coupled at all to the main thread. They'll just, you know, communicate via queues or something. And I think that's probably the way that we'll end up doing it. I can't promise that that will be true, but I think so. How much of a memory footprint is your game using already? Certainly it won't be large, but I'm more meaning how many different containers are there? How many different containers? Can you be more specific as to what you mean by container, I guess, and then I can try to answer that. Let's see, procedural generation of 2D graphics, is there some mainstream math for that? Well, it's not really mathy per se. There are some math elements to it, such as good noise patterns and stuff like that. But it's sort of more of a black art kind of a thing. Like, procedurally generating 2D graphics is, you know, one of those things that you just kind of gotta learn to work with. And like I said, we'll be doing some of it on the stream. Like, we'll be doing ground generation. We'll be doing much better ground generation than we're doing right now, for example. And so that'll be one place where we'll be kind of exploring that a little bit. What is my programming experience as before Handmade Hero? Oh, it's, well, I'm a game tech guy. I've been doing game technology for, I don't know, 20 years now or something like that. So I worked at Rad Game Tools, which is a company that makes like game libraries that are used in thousands of games, really. And I did a 3D animation system and a video codec while I was there. And then I've done work on actual games before, like just this most recent game I worked on was The Witness, which isn't quite out yet. It's a game you should definitely check out if you hadn't yet. It's John Blow's new game. And I did a bunch of work on the collision detection and the editor for that. So that's mostly what I've worked on in the past. I've worked on other things too, but you know, those are the notable things. Sorry for confusing with the terminology. JavaScript equivalent of classes. How many different classes are you having to use already? Well, I mean, sort of, I guess the answer is we don't use any classes. In that sense, we have some systems. So for example, we have a sim region, which is sort of a collection of things that's used to do simulation of a game area. We have a world representation, right? Which is sort of divides the world into chunks and allows us to quickly access those chunks. but we don't use classes. So classes are sort of a mental thing, right? Really, they're a way of breaking things down in an object-oriented sense, and we don't really do that. We sort of work with things in more of a systemic sense, where stuff is kind of grouped together, and so we have structs that define data layouts, but really our systems are a little more broader, and they're not really thought of in the same class way. But you can still think of them kind of similarly, like what you might think of breaking down as a class, you would think of as breaking down as a system in our approach. Thank you, Zamar037, by the way, for posting the OpenGL tutorial there. Hopefully that's a good one. I don't know if it is or not. Is that the arc synthesis ones? I'm not sure. Is there a simple way to explain pointers and references in C++? If so, can you briefly explain when you would use either? If that's too complicated, just don't worry about answering this. That is not complicated. In fact, it's not. There is no difference. They're a syntactic thing. So, trying to think of the easiest way to show this here. But basically, if I have something like int x, and then I have something like int star x, right? Or y equals x, I should say. Maybe I'll say pointer x. Then what this is doing is it's saying, all right, I would like the compiler to know that I am trying to refer to the memory, the first, like, I want a number that's the first byte of memory occupied by x, right? Because x is a 32-bit integer, it occupies 4 bytes in memory. I want a pointer to it, so I've taken the address of it and I can store that here. Now the compiler may never actually do that operation, because it only needs to do that operation if it's going to do something else with it later. For example, if the only thing I ever did with this, right, is dereference the pointer and set it equal to 3, then the compiler probably will never actually take the address of x and never actually produce a register with the address in it. It'll probably just know where x is on the stack and directly write 3 into it, right? Now, on the other hand, if I actually go to do something where that actually needs to be done in terms of taking the address, it actually will. For example, if I was to do something like have a memcopy routine or something, like some kind of like copy memory routine that's going to take that pointer to x, now it will actually do the work of figuring out where it is, putting that in a register and letting copy memory work on it or something. That might happen, right? Now, if I wanted to have a reference as well, right, where I do something like this, all that's doing is it's a different nomenclature for pointer. It's basically a nomenclature for a pointer, or what a pointer was representing, that does not need to be dereferenced in order to use it. So it's just saying, hey, look, I want you to essentially treat this essentially like a pointer, right? But now I'm going to call it a reference, and what's going to happen is everywhere I use it, pretend that I was just dereferencing the pointer that you had. So it's sort of just another name for x, right? That's all it is. It's another name for x at that point, right? But implementation-wise, it's still going to have to do exactly the same things that the pointer was doing. If it needs to figure out what the address is to point it to send it to something, like if I'm going to call something, like let's say this was giant for some reason. I'm trying to think what this is, like struct giant, right? Okay. So there's no way that that's ever going to be passed in registers, right? But if I wanted to do something where I was actually going to modify that thing, so I have a giant one, right? And now I've got a pointer to it, like so, and I've got a reference to it or whatever, right? And now I want to call some function where I'm actually going to operate on this thing, right? Well, if I was going to do it by pointer, so I have foo giant star whatever, like this. If I was going to operate on it by pointer, then we all know what would happen here. When I call foo with my giant, whatever it is, with my pointer to giant, it's just going to pass the address, and then this function is going to work off the address of that object to actually modify it, right? So, you know, if I wanted to here do something like this, suppose I shouldn't call this the same thing. There we go. If I wanted to operate off it like that, basically what it would be doing is it would be taking that address, it would be using this layout to know where it should go to operate on the 30th integer that's at that address, right? And it would do whatever the operation is I told it to do. Now, equivalently, if I was to make another one of these that took a reference to that thing and modified it, right? Now, this may look a little different because I'm using the dot operator and this is actually the bar. It's, you know, in some sense, it's actually a giant, not a pointer to a giant syntactically. In terms of what the compiler is going to generate, if the compiler has any sense at all, it will generate exactly the same code for these two foos, right? Foo1 and foo2 will generate exactly the same code in exactly the same way, hopefully. So really, it will still end up just being a pointer when the compiler actually uses it. So it's really just about how you syntactically wanted to treat that thing. It doesn't do anything, right? It doesn't actually have any different effect than a pointer effectively would in most cases in terms of what the compiler is going to do, right? So hopefully that helps a little bit. I mean, in fact, really, you could think of it as, unless you're trying to use some C++ features that need you to not use the dereferencing, like if you had some crazy C++ features you were caring about, you might need to use references, but otherwise you never need to use them. References, pointers just do the same thing. You would never actually have to use a reference. It's just a syntactic convenience for you if you prefer it. All right. All right. I think that's about it for questions today because I can't actually read the questions very well since the Twitch thing is down. I'll get that working tonight so that tomorrow we'll be in good shape. But I think I'm going to call it for today because it's really hard to read the Twitch stream without my little filter that normally runs on it. So yeah. All right. So I think that's it for now. Tomorrow, I think I'm liking where we're going with the ground thing. So tomorrow we'll do some more work on that and we'll get it to the point where we're actually generating a continuous ground. And then we'll maybe, the day after that, we'll start working on hole cutting in that. And the day after that, we can actually do multiple layers. So maybe, you know, by the end of the week, we'll actually have some relatively solid ground stuff drawing in there. And that would be pretty fun, because that's another pretty major to-do that'd be off our list. So, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the source code, you can pre-order the game at handmadehero.org using the little pre-order button, and it comes with the source code. You'll get a link in your email that you can use to download the source code anytime you want. And I think if I refresh the page, yes. And I added a thing down here to resend. If you've lost your order email, you can use this little have it resent button to have it resent to you. So that's pretty handy. I found out that I could do that with Sendowl, so I did that. So that's a good thing to know. If you want to support the video series, we also have a Patreon page you could subscribe to. It's always very much appreciated. We also have a news and forum site that has stuff on it, like a place to ask questions, ports to Linux and Mac if you're interested in following along on another platform, and episode guide for catching up on old episodes. There's also a tweet bot. I highly recommend subscribing to the tweet bot if you would like to know the schedule. It will tell you what the schedule is every day, as well as tweeting out on the weekends what the schedule will be for the week. So please check those things out when you get a chance. And I hope to see you back here tomorrow. It'll be 5 p.m. Pacific Daylight Time again tomorrow. Hope to see you here. Have a fabulous Tuesday, though, either way. Take it easy, everyone.